Okay, so some of these words should be very familiar from the first unit. So for example, when we're talking about an angle bisector, we've heard of angle bisectors before. What do angle bisectors do? Okay, what does bisect mean? Sorry, say that again. Divides the triangle. What part of the triangle? The angle, yeah. And how does it divide it? Just kind of randomly, or like?
There's no set rule.
What's that? Evenly? Okay, so that means like if I'm bisecting an angle, let's say this is an 80-degree angle. If I bisect it, what is each part going to be? 40. Yeah, so it's going to cut it directly in half. So let's remind ourselves, bisector divides something in half. So we can have angle bisectors, we can also have segment bisectors. I'll try and rewrite that so it's a little neater. There we go. So in a triangle here, an angle bisector is a segment that bisects an angle, which means divides it in two, and extends from the vertex to the opposite side of a triangle. So that's what we see happening right here. AD is the angle bisector. It goes from the vertex, which is A, to the opposite side of the triangle. And we can see our markings here that it is dividing this angle into two equal pieces. Here's a question. What about the opposite side of the triangle? Is that divided in half? Does that look like it's even on both sides? No, I would say no. So it does not bisect the opposite side. How many angle bisectors can a triangle have? It's not 12. It's less than 12. 3. It's 3, yeah. One for each angle, right? So we could do this angle, we could bisect this angle, and we could bisect this angle. They actually do all meet in one point, if you draw them all. It's kind of cool. So we'll do one example here. So letter A here says PQ is an angle bisector. Find the measure of angle 2 when the measure of angle 1 is 30 degrees. What would angle 2 be? Huh? 30, yeah. So it's pretty easy. It just means it's the same on both sides. All right, let's go to the next page. So now we have a perpendicular bisector. What does the word perpendicular mean? Megan. Yes. Instead of saying crosses, I'll say intersects, but yes, you're right. Intersects, or two lines that intersect to form a right angle. Two. Okay, and we know a bisector from the last one means divides into two halves, two equal halves. You could say two congruent pieces. Is another way to say that. So again, the word perpendicular bisector, or the term, is describing what this does. This is a segment that is perpendicular to a side of a triangle at the halfway point. What would we call the halfway point? The midpoint of that side. So here we have some pictures. We have a midpoint of a side, and then we have a line that is perpendicular at the midpoint. This is pretty similar to a mid-segment. What is the difference between a perpendicular bisector and a mid-segment? B. Lida? Okay, yeah, so the mid-segment is not at a specific angle. All right, that's not a right angle for sure. Maybe this one is, but maybe that's just random. What does the mid-segment connect? Mid-segment goes from what to what? Alessandro? Yeah, between two midpoints, exactly. Whereas this one goes midpoint at a right angle. So the other midpoint would be here. The mid-segment would go like this. Perpendicular bisector goes through one of the midpoints, but what's special is that it's at a right angle. How many perpendicular bisectors could a triangle have? 3, yeah, one for each side. So there's the midpoint. It could be right there. And then for this one here, here's the midpoint. It would be right there. Mm-hmm. Yeah, they do all intersect from the same point. Yeah. Okay, so we'll do one example here. DE is a perpendicular bisector, so that means I can put a right angle here. I can mark those two the same. Find the measure of angle C if CDE is 35 degrees. Jackson, what do you think? How could I figure out the measure of angle C, that bottom one there?
You could maybe, well, no, that one's 90.
Mm-hmm.
No, the other one's what, 35? I can't see very well.
Yep, 35, yep.
They equal 180.
Nice. So we do 180 minus 35 minus 90, and we would get 55 degrees. Nice.
Yeah, you should give me a hard one. I wasn't there.
Yeah.
No.
Maybe that's the answer. Let's go to the next page. So now we have the altitude of a triangle. What's another word for altitude? Height. Yes. So altitude and height are the same thing. So if we wanted to measure how tall this triangle was, That's what this segment is doing right there. It's measuring from top to bottom, from the lowest point to the highest point. So altitude is a segment from a vertex to the opposite side and is perpendicular to that side. Okay, so what's the difference between the altitude and a perpendicular bisector? Mia.
One side of the thing goes to a side, and then the other goes to an angle.
And the other goes to what?
Goes to an angle.
Okay. So yeah, so the perpendicular bisector, when you were seeing that, yeah, the other end of it was here, kind of in the middle of the side there, whereas the altitude is intersecting the angle there, the vertex. Yep. Lee? Okay. I would say there's one other difference. Yeah.
It makes another triangle instead of a four-sided shape.
Okay, yeah, so the altitude is cutting it into two triangles, whereas the perpendicular bisector, yeah, you're right, as it comes here, it makes this weird four-sided shape. Yeah, it's a good observation. What about the other end of the perpendicular bisector? What about that point right there? What's special about that? It's the middle, yeah, it's the midpoint. So perpendicular bisector goes through the midpoint, altitude just goes through the vertex, as you noticed before. Yeah, so I think all those things are correct. They can look similar because they both have right angles, but they are different. Okay, let's go to the next page. No, or not yet. So our last segment is the median of a triangle. As you can see from the picture here, you've got one endpoint is the vertex, the other endpoint is the midpoint of the opposite side. So a segment from one vertex to the midpoint of the opposite side. Oops. Jackson, turn on, please. Okay, here's a question. Does this bisect the angle? What do we think? Does that cut that angle in half? Let's zoom in. Do these angles look like they are the same size?
Can you erase your line?
This one? I don't think so. This one is definitely smaller than this one. So it does not bisect the angle. So this is kind of the opposite question that I was asking for angle bisector. Right, we said an angle bisector does not bisect the opposite side. These two pieces here are not equal, but the angles are. So this is now the opposite of that. We are bisecting the opposite side, but the angle is not bisected. Yes, and so they would be very similar. Angle bisector would be like here, maybe right next to each other, but they're different. Not opposites necessarily, but similar. Now, the exception to this is if we have an isosceles triangle. What does isosceles triangle mean again? Two sides are the same. So in an isosceles triangle, this one from the very top is the median, it's also the angle bisector, it's also the perpendicular bisector, it's also the altitude. Jackson? It's your last word.
Put a parking one there.
Levi? It's your last one. Okay. So in isosceles triangle, you have the one from the top angle there. It's going to be all four of those special segments. Let's go to the next page. Okay, so given a picture like this, we've got all four of those segments we just talked about kind of in the mix there. We want to be able to distinguish them. So we're given this information right here. Tell me that angle CBF, that's this one, is congruent to FBA. So as I'm doing this, if I want to identify the altitude, what am I looking for with an altitude? What's that? What? What are we looking for?
From the highest point.
So something from the highest point, okay. CE. Do we agree with CE? Yeah, I would say I'd be looking for vertex to a right angle. So there it is right there from the vertex. And there's the right angle down there. Okay, name the median. What am I looking for with a median? Or who thinks they see which one it is? FB? I would not say it's FB. It would be AD. So for median, I want vertex to midpoint. HG is the next one. So here's vertex to midpoint. Perpendicular bisector. Which one is it? Which one's a perpendicular bisector? GH. So I'm seeing midpoint and right angle. So here's the midpoint, and that one's there at a right angle. So this one does not go through the vertex. And then last but not least, where's the angle bisector? Process of elimination. Awesome. FB. Yeah, so that we were told this angle was bisected in the beginning. That'll be that one right there. I forgot to name these. Okay. So I want you guys to do the next 4 problems. There's one choice missing, so choice B is perpendicular bisector.
We didn't write that in.
Yes. All right, let's check these. Okay, so XF I see vertex to the other side. But I also have this given information here that says these two angles are congruent. So what is this one? It's the angle bisector. Okay, CD, I see a right angle. This is not a vertex. And I see a midpoint over here. So if I see a right angle and a midpoint, what would I say? Perpendicular bisector. For ZB, I've got vertex to right angle. What goes vertex to a right angle? The altitude. And hopefully that means YA is the median, but I'm seeing I'm going vertex to opposite side, and that's the midpoint. So which one goes vertex to midpoint? Is that the median? That is the median. Good news for us. Okay, so which three segments have the vertex as one of their endpoints? The angle bisector, altitude, median. All of those go through the vertex. Alessandro. So those are the two segments that are always perpendicular to a side. Remember, perpendicular means right angle. So yeah, that's altitude, perpendicular bisector. Very nice. I'm actually going to change number 3 a little bit. I'm going to say name the 3 segments that always include the midpoint of, I'm going to change this to a side. Because there's one I don't want us to forget about. Okay, so what 3 segments include the midpoint of a side? Who's got one? Wait. Okay. Median, perpendicular bisector. There's 2 of them. There's one more. Okay. The mid segments. Nice. Okay, I don't want us to forget about mid segment. Really, I think that should be part of these notes, but you know, I don't make the rules. Ms. Gilbert. Ms. Gilbert. The one who makes the rules.